This is our third video in our series on forensic analysis of glass and paint. We're going to talk about how we determine the refractive indices of glass and how we use them. So there is a qualitative and a quantitative way to determine glass's refractive index. The qualitative method is useful for estimating the refractive index value, and this is what's known as the oil immersion method. So what you do is you immerse the glass in oils that have a known refractive index. And when the refractive index of the glass and the oil are the same, you won't see the glass's outline anymore. It will just disappear, and that's called optical homogeneity. When you have something of two different refractive indices, you see what's called a Beck line, which is a bright halo around the glass fragment in the oil. If you're looking at this underneath a microscope and you raise the focus of the microscope, it moves towards the medium with the higher refractive index. And this happens because the polarized light from the microscope becomes concentrated around the edges of the glass fragment. And then, so once you've done that with one type of oil, you're going to remove the glass particle from that oil, and then you're going to repeat that with an oil with a higher refractive index, and this will allow you to get a kind of rough estimate of what the refractive index is. Then there are quantitative methods to measure refractive index. We'll give you an actual number. First of these is called the Hotstage Method. You heat the glass fragment submerged in an oil of known refractive index. And you have a computer attached to this setup that's going to study the variations of the refractive index with temperature. The oil refractive index decreases with increasing temperature, and the refractive index of the glass increases with increasing temperature. And the computer is going to look for a match temperature where the refractive indices of both substances are going to cross. This type of microscope works with a type of illumination system called phase contrast, and this is particularly useful when you have clear particles that wouldn't be visible using traditional bright field light. And so you select an area on the edge of the glass fragment, and the detector will record the temperature where the fragment disappears, and then it translates that into a refractive index for you. Some other ways that they can quantitatively define the glass, they can use a scanning electron microscope with energy dispersion spectroscopy, and that will give them a printout showing the elemental composition of the glass. X-ray fluorescence will do the same thing. Laser-induced breakdown spectroscopy and laser ablation inductive plasma mass spectroscopy will also do all those things. So all four of those techniques are designed to give you a readout on what is the actual elements making up the glass.